Hey guys, welcome back to the channel. Recently I dropped a video discussing whether or not I would get the new Staccato HD C4X. So this is the gun that they just showed at SHOT Show that has the integrated comp at the end, aluminum frame, 4 inches, yada yada yada. A lot of the discussion from you guys was whether or not the price increase essentially of $1,000 was warranted or justified. So in this video what I'm going to do is I'm going to draw up my current Staccato C barrel. I'll make a configuration of it with an integrated comp at the end, and then I'm going to send these files off to a master machinist and see what he thinks the cost delta should be. So let's get into it. Alright guys, here is the Staccato C barrel. I took some very crude measurements of the diameter, the overall length, and kind of the width and height or depth of this sort of inferior protrusion down here that kind of connects the link. I was going to take this with me on a business trip. I had to go to the northeast portion of the states here, way up in Maine, earlier this week. I went super early Sunday to beat the snowstorm. I beat the snowstorm and then was basically sitting in my hotel room watching football. So I thought, hey, I could take some time and draw this barrel. I was going to bring the barrel with, but I was like, dude, what if I get stopped by TSA and I can't bring this? Now I'm out a Staccato barrel. So I took just a few crude dimensions, this diameter here, the overall length, and the dimensions of this guy, and some videos and pictures, and basically just kind of drew this by eye and by feel. And I think we got pretty close. Okay, so here's kind of the finished model, and you can see it's pretty close. Now I know that the depth of these lugs are probably off, but again, I didn't even have the ability to measure them, so this is all just kind of by eye and by feel. And let's kind of scroll through some of the CAD philosophies to efficiently draw this in CAD. So I'm going to go to the feature tree here and just zip it all the way up to the very first feature. And this first feature is just a cylindrical extrusion. So I measured the barrel. It came out at 695 at kind of this big fattest portion here at the very distal end, and just extruded that as a cylinder. And I did have a depth that I measured with the caliper of about roughly 4.05 inches, and that's my first feature. Next, I kind of roughed in that sort of inferior protrusion we were just talking about. And basically, I just went on this front plane here, just drew a sketch. Now, I did take some of these measurements with a caliper before I left. So I had these two features basically when I left for my trip. Everything else I added in the hotel. The next thing I did was I wanted to throw in the barrel sort of rifling and the kind of the idea of the barrel. I started out with a helix, and the helix is important because that's going to give me my twist, and then I was going to do a sweep cut or a cut sweep to kind of get that in there. So this particular helix, I just eyeballed this thing at roughly 0.2 revolutions. You can see here. Don't know over the given height or length of this barrel. Don't know how accurate that is, but it looked by eye pretty close. So got that helix in here and then did a hexagonal swept cut. And that gets me, I'll zoom in a little, kind of that bore rifling there going on. So it looks cool, but you know how accurate it is, I don't really know. Again, I was just eyeballing everything. Next feature I put in was that sort of underside flat on the bottom of the barrel. That was just a very simple sketch on this front plane here, and just extruded that through all in both directions. I just eyeballed some measurements and dimensions. Next, we put in kind of this lead-in series of cuts from the side profile. Now next, I made a plane. I forget what this was for. This was for the first kind of like locking lug cutout. Okay, so this, I made a new plane, and I just gave it a eyeball distance from this back plane here, and made this sketch, and extruded it a given distance. I'm sure that distance is wrong if I was to measure it with a caliper. I went 175. I don't know how accurate that is. I don't really care for the purposes of this exercise. And then I used a linear pattern to get a couple more of these cuts in there. So this will stay as is, and then this one will eventually now lead into the very distal end of the bull barrel. And that sort of 12 o'clock kind of taper you see here, I'm going to get with a swept cut. So you'll see that in this next feature here. And that was simply done by essentially stealing the sketch that created the cutout for these lugs, and then creating the profile for this cut sweep. And you'll see that here. So, I've got this sketch here of this swept cut, and then I've got this sketch. And if I edit profile and edit feature on this guy, you can see kind of how that removes material. Okay, so that turned out halfway decent. It looks like the barrel does. Next here was just kind of a series of just trimming material to make it look more like the real part. Now this is actually incorrect. This shouldn't cut here, but whatever. We're going to leave it the same. So I got the sort of inferior lead in there, that inferior ramp, top side, a little chamfer on that edge. Now I start getting some fluting in here. So to lighten this up and also to allow oil to kind of reside in there, there's a series of these cuts. Which one was this? Oh, this was the interior cut of that inferior protrusion. I think next is going to be probably the lightning cuts. Yep, these scallops here in cut 11. And these were just straight extrusions of a 75 thou diameter circle. Pretty simple. And then to kind of fill them out, to simulate a ball end mill making these, I put these fillets on the ends. So you can see this guy here at all the ends of the grooves. What was this one here? Oh, this was just for the side profile cut feature. Next, I shape cut the bottom of the inferior protrusion. Then the last thing I kind of messed with here was getting this sort of cutout up top. What I did here to do this is I made a plane at an eyeballed angle. I think it was about 45 degrees. Put a sketch on that plane. So here's the sketch on that plane, and then I projected that sketch onto this surface to make a composite curve. And that's what we see here. So this is a composite curve. And now this can be treated as essentially a three-dimensional sketch for a cut sweep feature. And boom, there you've got your sort of four-axis kind of ball end mill jog here. And then I just simulated kind of these little cuts in here as well. Now, these would actually have some little ribbing structures in here, but for the purposes of this exercise, I think this is close enough. So now what we'll go ahead and do is we'll put a compensator on the end of here. So I'm going to pause. Okay, boys, so we left off with just the nominal Staccato C barrel. Now we'll get into the additional configuration, which incorporates the integral compensator at the end, with ports kind of at the 12, 3, and 9 o'clock positions. So you can see here in this feature tree I'm pointing to with the cursor, I made a secondary configuration called with integral comp. So if I click on this guy, ding dong. So again, this is just based on my Staccato C dimensions, kind of driving some of this geometry here. In addition to looking at certain pictures, I really couldn't get a good view of the 12 port except for one video from SHOT Show. So again, this is just going to have to be kind of a close enough representation. So let's go over to the feature tree here now. And what I did is I grouped all the features that are specific to the compensator, the integrated compensator, in this folder here called Comp Features. Obviously, you can name it whatever you want. This is just kind of a good common practice to get in the habit of, so you can kind of easily find features in the tree that you're looking to maybe adjust later. So we'll go ahead and you can see I've got, geez, I don't even know how many different features here. We'll roll back in the tree and you can kind of see the visual progression of these feature sets. So I started this off by going off the end face of the barrel. I'll just kind of hide this feature. So I picked this surface here as a sketch plane for the first main Boss Extrude 3. And you can kind of see highlighted blue here are the sketch features that I input. I'll just go ahead and edit that so you can see. I did some actual measurements with my Staccato C upper slide and, you know, eyeballed things as best I could. So now the extrusion distance I had to kind of swag off of pictures off the website. So I think on this I went, let's see, like 450. So depth of 450, that could be off. I don't know, but for purposes of this exercise where I'm just giving these two CAD files to a very experienced machinist, and we'll kind of get his general take on, again, like we've already talked about a million times, how much more machining complexity and time you could expect with the more complicated integrated comp version. So after kind of this main body extrude here, let's see, what did we do next? Here I did sort of a side profile cut, and if I just kind of get normal to this, so again, this was some eyeball swagging here based on the picture, so I put the slot in here and kind of this irregular shape for the 12 o'clock port, and just extruded everything through all to, you know, get the cuts as we see them here. Next, what did I do next here? Oh, I extruded the 12 o'clock feature down a little bit more so that I would get a nice flat surface, as you can see there. And in this one, basically, I just stole all of the previous edge geometry from the side profile extrusion that I did in Cut Extrude 18. Next, I created a plane. What did I do that for? Oh, yes. So what I wanted to do now was make a cut loft from this surface down to some arbitrary surface down here. And that will make more sense as I show you the next feature. And so I kind of did a cut loft to progress from this flat cut surface and just to sort of almost artificially draft it down, but drafting it down in such a way where only the sides are ingressing inboard towards the barrel axis, and no sort of draft or ingress from either the distal or proximal sort of subsurfaces of the original cut. So pretty simple feature there. And again, it's hard for me to gauge what the actual geometry in the 12 o'clock port is because I just can't really see any pictures of it, and also I don't physically have one yet. So next, we kind of cleaned up some of the remnant geometry with just another cut. And I think on this one, yeah, I just extruded up to a vertex here. Just basically cleaning this up all the way down to this point you can see here. From there, I filleted some of the sharp internal edges. So those will be highlighted here. And I'm taking kind of some creative liberties here because I just don't know what it actually looks like. Next, I made sort of a round exit hole at the end of the integrated comp. And then from here, I incorporated this edge chamfer, which you can kind of see in some of the pictures, and just continued with a series of chamfers. This is the kind of the big chamfer to sort of match the angulated facet on the lower, and repeated that over on the other side as well. To make these, what I did was sort of a three-dimensional, dimensionally derived chamfer, where I basically measured kind of where the Staccato C facets are and inputted these 3 dimensions here, roughly 1/4 inch, 65 up, and 1/10 of an inch inboard. So 1/4 inch back, 1/10 of an inch over, and 0.65 up, and that was proliferated to both sides. Next here, I added these sort of edge break chamfers on the 3 and 9 o'clock positions. And again, I'll rewind that and roll it back forward, and you can see that edge chamfer come into play. Next, we proliferated. It took a series of chamfer features to get this jogged sort of perimeter chamfer all the way around the 12 o'clock port. So I had to do that, I think, in these 3 separate chamfer features. And this is just kind of a weird anomaly with the software, why I had to do that. Just sometimes these things can be weird when you're jogging a chamfer or a fillet along an irregular tangential group of edges, essentially. So I think for me, that's probably close enough. Is there a bigger hole in this backside here? I don't know. I can't see it. But for the purposes of this exercise, I'm calling this close enough. So now I'm going to ship both of these models off to my machining expert, aka my dad. Okay guys, we've looked at both barrels. I've sent them to Min for him to kind of look at and give me some guidance as well. I made a little PowerPoint here to kind of go over the cost increase structure for a company like Staccato. So basically, the production cost increases can kind of be broken down into 4 general categories. We're going to have an increase in raw material cost, an increase in machining costs, some sort of mild increase in finishing costs, and then some sort of general scrap and quality control increase. So if we look at the raw material costs, these barrels are made out of 416R stainless. So Min gave me some sizing swags for just the normal barrel and then the one with the integrated comp. Not a huge size delta, but enough to where in 416 stainless, which is cheaper than 416R, it's roughly $15 more expensive to make the integrated version. So I'm going to call this roughly a $20 increase in material costs. Next is the machining cost increase, and this can kind of be broken down into a few sub-segments. The first one is no matter how they're going to machine this thing, there's going to be additional machining time. Depending on whether they're using 4 or 5 axis, Min estimated anywhere from a 25 to 40% more machining time to construct the integrated comp barrel versus just the standard barrel. There's a second kind of subheading here. If they are using 4 axis nominally and decide to use 5 axis for this, just running a 5 axis CNC, those machines are more expensive, and the capital costs to acquire those and support them are going to be amortized over an hourly rate to run that machine. So, you know, an hour in a 4 axis is typically going to be cheaper than running an hour in a 5 axis. The third kind of subheading under machining cost increase, you're going to have substantially more cutter cost and tooling wear and potentially breakage. So to get all those little intricate ports into the end of the comp, you're going to need much smaller diameter cutters. These are going to wear out a lot faster. And I would assume a production facility such as Staccato are going to do cutter wear studies, and they're going to have a fixed amount of either runtime or number of barrels produced to where they're basically swapping out cutters, you know, at a specific, it could be time, it could be, you know, every 40 barrels we need to swap out these cutters. So that's always an increase in kind of recurring costs there. And then the last one is you have a higher
likelihood or potential for having something go wrong in machining. If you break a cutter while doing some passes inside one of the comp ports, basically that whole thing is now scrap. So with the more intricate and involved machining, that's always a higher risk. Next, we'll talk finishing costs, and this can be broken down into tumbling after machining, the heat treatment process, the DLC coating process. Those are probably the three main things I can think of. Now, in terms of tumbling, probably the exact same process, but in the vibratory tumblers, chances are they're going to be able, or they're not going to be able to put in as many integrated comp barrels as they are with a standard barrel. And how the tumbling media could get compromised within the comp ports, there perhaps could be some additional hand finishing required to kind of get in all those nooks and crannies. Heat treatment, I'm assuming, is basically a wash. The only small but to that is, I'm assuming Staccato does heat treatment in-house. I'm assuming they use their own ovens. Ovens typically obviously have a fixed volume, and they may not be able to put quite as many integrated comp barrels in the oven as with just a standard barrel, but that's all speculation. And the DLC coating. Presumably, there's going to be a little bit more prep time involved to ensure that the surfaces are prepared properly for the DLC coating process to, go smoothly and adhere as intended. And as a result of that, there's a higher potential or likelihood for having post-DLC coating aesthetic blemishes, which basically will scrap the part. And then finally, we get into QC and scrap. I have no idea how and when they inspect barrels. Do they do it after machining, after heat treatment, and after DLC finishing? Don't know. I know heat treatment can sometimes influence and change dimensionals slightly. And obviously Staccato is a volume-ish manufacturer of 2011 such that they want these barrels to be as drop-in as possible. And as such, the dimensional control throughout all these machining and finishing processes is going to be critical to minimize hand fitment time down the line. So this could manifest itself in increased vision system or CMM time, or just purely human visual inspection time. The more complex components are going to more likely have a higher potential for increased quality control failures and higher scrap rates. We already kind of talked about wanting to be drop fit or drop in, and just generally scrap is going to be higher across all phases of producing a barrel with an integral compensator. So if we try to assign values to all of these kind of subtopics, I swag roughly $20 for material, $150 to $200 for machining. That depends on a lot of different factors in terms of what type of machining centers they're using, et cetera, et cetera. A slight increase in finishing costs just due to not being able to have the same quantity of scale for each sub-finishing process. And then finally, the quality control and ultimately scrap kind of baked into that fourth subheading there. So overall, I'm estimating a internal cost increase for Staccato to manufacture these integrated comp barrels of roughly $200 to $250. And lastly, let's address some of the comments in that last video I had about talking about the C4X. Guys were like, just get a HD P4 and have it, send it out to have it comped or ported or whatever. And some guys were throwing out some really crazy low prices to have that done, and I don't think you guys are thinking this all the way through. Let's just take the HD P4 as an example, and we'll use Monsoon Tactical because a few of you guys did reference to use them, right? I've never sent anything out to have custom ported, so we looked on the Monsoon Tactical website here, and this is for the Staccato, Prodigy, Platypus, whatever. This is for the 2024C, okay? The P4 HD. So let's assume we're going to do this to the P4 because I want a 4-inch gun. I don't want to get the 3.6. That's too small for me. So the P4 HD, okay? And so if we scroll down here, the Master Genghis Comp package, if we just have it coated a single color, Cerakote, this is 450 bucks. Okay, let's say we choose their, what do they refer to it as? Color case hardening finish. Now we're talking $675. And then you see right here, 14 to 16 week lead time. So $675, okay. Now let's go to the Staccato webpage. Let's say we bought the P4. Let's say we bought the cheap version for 2,500 bucks. So, and then I'm gonna spend another $675. Let's say there's shipping and something else in there, 700 bucks. So this costs $3,200. And I'm not gonna have the gun for, what, 4 months? And I'm gonna lose my warranty? Like, I think that kind of thought exercise just shows you where Staccato is pricing this HD C4X is probably pretty reasonable. But anyway, oh, and I forgot the last little point here. Even if you went that route, where you'd have like a custom ported slide and barrel, you still lose the benefit of having weight at that comp weight at the end of the gun. So there's that as well. Anyways, what do you guys think? Leave your thoughts and comments down below. Go ahead and flame me if you want, but I think I've talked myself into getting this thing. That's all I got, boys. Peace out.